Well, alrighty then. See how this turns out with my brand new iPad, everybody. All right, so given f of x equals the parabola x squared minus 1, describe the transformations of these that have occurred for each of the following. All right, so the first one is 5x squared minus 1. Well, that is a vertical stretch by a factor of 5. It is now 5 times as steep, 5 times skinnier maybe, but that's a vertical stretch right there, multiplying x squared. This one is x minus 5 squared plus 4, so that is a shift to the right of 5 units, and up a surprising 5 units, because we were down 1. This minus 1 here was taking the parabola and shifting it down 1 unit. It is now up 4, but that's a total of 5 from where it was. So it's shift right and up 5, not 4. The next one, x squared plus 2, that is a shift of up 3 units. Okay, once again, we're down minus 1 to begin with. Now we're at positive 2, so we have gone up 3 units. This one here is a vertical flip because of the negative sign, and a vertical compression. That is, the parabola has gotten kind of squashed, opens up a little bit wider and fatter than it did before because of that 0.4. So vertical flip over the x-axis and a vertical compression by a factor of 0.4. Last one is 4 times x plus 5. So the whole thing has been shifted to the left 5 units. It is vertically stretched, and because there's no longer any minus 1 in the equation, it has now been shifted up 1. Okay. So here's our two functions, f of x and g of x. G of negative 5 means to put a negative 5 in there into g, and that gives you a negative 5 total. 2 times negative 5 is negative 10. Negative 10 plus 5 is negative 5. F of negative 2 is 1 over negative 2 plus 2. Negative 2 plus 2 equals 0, so 1 over 0 is undefined. That one's kind of interesting. The next one, f of g of 0. So you put a 0 into g, which is this right here. All right, so g of 0 means 2 times 0 plus 5. That gives you 5. So now I want to find f of 5. So f of 5 means 1 over 5 plus 2. That's 1 over 7. The next problem, g of f of x means to take f of x and put it into g. So there's f of x, so I'm putting it in right there in place of the x in g. So 2 times f of x, 2 times 1 over x plus 2 plus 5. And there's not too much simplification you can do with that, just multiplying straight across. 2 times 1 is 2, so it's 2 over x plus 2 plus 5. Remember, when you multiply a whole number times a fraction, you do not multiply the denominator, just the numerator. Okay, last one, g of g of g of 0. G of g of g of 0. Put a 0 into g, right there. 2 times 0 plus 5 is 5. Now I'm going to take 5 and put it into g once more. 2 times 5 plus 5 is 15. Now I'm going to take 15 and one last time put it into g. So 2 times 15 is 30 plus 5 makes 35. Alrighty, next problem. All right, so here we're bouncing back and forth between these columns on the table. F of g of negative 1. G of negative 1, okay, our input is negative 1. G of that is positive 3. So that means f of 3. This part equals 3. F of 3, come down here to 3 in the input column, gives you negative 2. This equals negative 2. G of f of 0. All right, so f of 0, there's 0 in the input column. F of that is positive 2. So I want g of positive 2. There's 2 on the input column. G of that is 0. This equals 0. F of g of 3. Here's 3 on the input column. G of that is negative 1. So I want f of negative 1. Negative 1 on the input column. In the x column gives me negative 1. That equals negative 1. Finally, we got triple whammy here. F of 4, all right, turns out to be 3, all right? So I want g of that. That means g of 3. G of 3, there's 3 in the input. G of 3 is negative 1. So this is f of g of 3. That means f of negative 1. And if you check that out, negative 1 means negative 1. Actually, we kind of did that right there. So back to that one. All right, on the next page, Here's your graphs. All right, there's your unchanged f of x, kind of a weird looking little hat-shaped graph. And if I'm taking f of x minus 2, that's down 2. So I'm just shifting this thing down 2 units. However, if I'm taking f of x plus 2, that's a left shift of 2 units. Okay, so this thing just slides to the left that way, 2 units. So it's over here now. Okay, and then the last one is negative 1/2 times f of x. So that is a vertical flip, that's what the negative sign does, and a vertical compression. It is now being squashed down by a factor of 1/2. So it started off like this, so you can imagine flipping it over, all right, and it looks like this now, this green shape. Okay, a couple of different ways to do number 5. I've got the function square root of x squared plus 4, and I'm trying to ask you to come up with 2 different functions, f of x and g of x, such that our square root of x plus 4 equals f of g of x. Turns out to be more than one way to do that. If one of the functions is square root of x plus 4, and the other function is x squared, I can take g of x, plug it into f of x, and that gives me the square root of x plus 4. But there's another way to do it too. If I have my outer function is just the square root of x, and my inner function is now x squared plus 4, taking x squared plus 4, putting it in place of x in f of x gives me the same thing, square root of x squared plus 4. So 2 different ways to do that kind of. And the last few problems are kind of random equations to solve, so don't forget how to solve equations. Here's a radical equation, so I subtract 18 from both sides. That leaves me with the square root of 3x equals 6. 24 minus 18 is 6. Now to get rid of the radical, I square both sides. So that's what the little red parentheses and exponent is. That just leaves me with 3x all by itself equals, and 6 squared is 36. 3x equals 36. I divide both sides by 3. I get x equals 12. Next one. This is a quadratic, and it can be factored. That factoring is the easiest way to solve quadratics. This factors to x minus 12 times x minus 3. I'm looking for numbers that multiply to 36 and add up to negative 15. Well, if they add up to a negative, that means both of them are negative. And of course, negative times a negative is positive. So 2 numbers that kind of multiply to 36 and add to 15 are 12 and 3. So x minus 12 times x minus 3 equals 0. That means x minus 12 equals 0, or x equals 12, or x minus 3 equals 0, or x equals 3. Next problem is kind of a straightforward linear equation to solve. I multiply through with the distributive property. That gives me negative 15x plus 10. Don't forget, negative 5 times negative 2 is positive 10, equals 4x minus 9. Now I'm going to try to get all my x's together. So I'm going to subtract 4x from both sides. That leaves me with negative 19x over here plus 10 equals negative 9. The negative sign follows down. Don't lose that guy. I'm going to subtract 10 from both sides. And that gives me negative 19 over here. Negative 19x equals negative 19. That means x equals 1. Last problem. One fraction equals another fraction. Cross multiply that guy, all right? So 8 times 2x is 16x, and x minus 3 times 7 is 7x minus 21. You set these things equal to each other, all right? So that means 16x equals 7x minus 21. So I'm going to get my x's together first, subtract 7x on both sides. Always got to get your x's on one side of the equal sign. So 16 minus 7 is 9. 9x equals negative 21. So that just means x is negative 21 over 9, which does reduce down to negative 7/3. Or if you used a calculator, you would have gotten negative 2.3 repeating. And that's it. Hope you enjoyed that. If you have any other questions, post them in the forum. All right. Bye.